All right. So welcome to this wonderful vBrownbag edition. We've got Elver, Sena, Sosa,
Hi.
and Anuj from Brocade. And I'm Richard Hackman.
Hi.
So we're going to ask some questions about NSX and Brocade and kind of how they work better together. So Anuj, what is Brocade doing in the software-defined data center space?
So Brocade is actually providing a lot of different integration points with VMware. So I'm going to talk about a couple of things, and I'm going to actually show a slide on it so that you guys can follow it easily. So the integration points that we talk about are the choices that Brocade provides for the underlay. So we provide choices like layer 2 class and layer 3 class. We also have integration as far as the Brocade switches themselves. They're very, very easy to manage and integrate. So the whole idea behind NSX is that it's automated, right? And that's the same philosophy that we follow when we build the Brocade VDX switches. So they are also very easy to deploy and manage. The third integration point that we talk about is the Brocade VDX gateway. It provides the bridging between the virtual and the physical domains. And finally, we integrate with the vRealize operations as well, which provides visibility and monitoring into the SDDC infrastructure. So as far as Brocade is concerned, we are absolutely committed to the NSX environment. We have several points of integration, as I just talked about.
Okay. All right. So let's talk a little bit about the NSX requirements for an underlay. What does Brocade have there as like a differentiator?
So I did mention the choices that we have for the underlay. I talked about the layer 2 class and layer 3 class. So I'm going to put up some slides there as well. We provide choices. The first choice is layer 2 class. Most of us who are from a networking background are familiar with the concept of a leaf and a spine architecture. So you build the underlay network using leaf and spines. When you build it using Brocade VDX switches, you can actually cluster the VDX switches together and form a VCS fabric. The whole idea behind a VCS fabric is that the switches which are clustered together, they can be managed as a single entity, right? And this concept is called logical chassis.
Now, Anuj, in that case also, do they also have a single control plane for all the switches there?
Absolutely.
So they appear like a single big switch to anything that connects to it?
Absolutely. So the whole idea behind logical chassis is that it's a single entity as far as the control plane is concerned, and also a single entity as far as the management plane is concerned.
And how easy or hard is it to get that up and running?
So we also provide zero-touch provisioning. So what we do here is that the first switch that comes out for the fabric, that needs to be configured to say that, okay, this is the VCS ID. Following that, every other switch that comes up in the network, that gets zero-touch provision.
So the first one has to be told what VCS it will belong to, and then it will tell everybody else
Absolutely.
as they join the fabric.
Correct. So that even the first switch, the stuff that you need to do is just one line of configuration, right? You just tell it what fabric ID it belongs to. After that, every other switch that joins this fabric, it is automatically provisioned. And that's one of the key differentiators that we have. So when we built the Brocade VCS fabric, we were always thinking about embedded automation, right? So how do we make it easy for the operator to build and manage this network? And that's where we also talk about things like, and I'm going to talk about point 4 here, just skip to that. We talk about zero-touch provisioning. We also talk about self-forming trunks. So if you already have a VCS fabric in place, and if you want to add a new link to it, then that link does not need to be configured at all. Because the switches are already part of the VCS fabric, that link will just come up, and you can actually load balance traffic using those links as well.
I'm sorry, so are you saying that you can add capacity without having to make any configuration changes?
No configuration changes at all. Just get your technician in the lab, have him connect between the ports, and the links will come up, and load balancing will take place automatically.
So basically, the skill set for the technician to do this job is rather lower threshold than the traditional data center engineer that needs to know how to configure devices.
That's the whole idea of the VCS fabric, right?
Oh, that's
the value proposition we bring, and we call it embedded automation. So lots of automation features built into the fabric itself.
So based on that, actually, how would you see that fitting into an NSX deployment and even scaling it?
Actually, that's very reminiscent of how NSX works, because when you have NSX and you already have a cluster configured, and you add another host, another member to that cluster, NSX would automatically configure that host, give it all the information that it needs so it can do NSX, and workloads would automatically be redistributed to that, migrated to that host using DRS.
Elver, we
so that the
actually
close
have a
path-
slide about it, so
Oh,
we
go
can
for
actually
it.
talk about that in that context. And let me skip over some of the slides here because they talk about how Brocade can be used to build the underlay architecture. So what Elver was mentioning is how auto provisioning works across the physical and the virtual domains. So Elver, would you like to talk
right
through
here,
this?
That is exactly right. Because in this slide, what you can see is that when you want to add capacity to your data center, let's say you want to add another rack. In that rack, you're going to have new leaves on the top of the rack, right? The top of rack switches. And historically, you will have to configure manually those switches and the spines the switches can configure to. But as Anuj just mentioned, because of the BCS fabric, you just have to plug and play those switches and the switches get configured automatically. And then when you add the host to that, to connect the host in the rack to that switch, as using auto-deploy features from VMware on the vSphere, those hosts will get the configuration, be placed in the correct cluster, be placed in correct BDS, and at that point, NSX will kick in, configure the host, prepare it, install the NSX bits that it needs to go there, give it IPs for the B tabs, and then DRS comes in and rebalances the load in the cluster.
So
And
Elver,
all you had to do was have somebody that was strong enough to do racking and stacking.
All right.
Right.
So, but being realistic, not all the workloads are going to be necessarily in the virtual space. So, is there some other means to address that?
Actually, that's very realistic. So let me go back to a few slides. I think Anuj had a slide here that talked about that. Yes. So Brocade with the BCS fabric can do a VTEP, which is a VXLAN tunnel endpoint, a VTEP for the NSX ESXi host. So if you have a workload, a virtual workload, that has a application need or any need to have a layer 2 connectivity to a physical workload, like a database, for instance, you can have the host that is running that VM terminate the tunnel in the BCS fabric itself. And then the BCS fabric will open the tunnel up, take the traffic from the VM, and then drop it on the VLAN where the physical workload is running. Now, that by itself sounds like, it sounds okay. But what's good about this is that the BCS fabric, because it's a fabric, can have up to 4 different members of the fabric. Typically, you put them in the spine that can all terminate that tunnel. They will all share that VTEP with themselves so that the ESXi host, when he sends the traffic to that VTEP, the fabric will decide which of the 4 will get it, and that one will decapsulate. So when traffic goes from the VM to the physical workload, it goes VM, physical host, the host that is running the VM, then it goes to the top of rack, the leaf. The leaf will choose one of the 4 switches that is terminating the tunnel. The switch decapsulates the tunnel and then forwards it to the destination traffic on the physical workload.
So, Elver, are you telling me that you have actually 4 VTEPs in the fabric?
No, you only have 1 VTEP. And the trick is that all 4 of them will present themselves as the same one. Just like the BCS fabric, which can have up to 48 members in it, will look to be just one to anything connecting to it. The 4 BCS terminating the BXLAN present themselves as the same VTEP to anybody that's been in the tunnel.
So there is one VTEP which is distributed across the spine layers.
That is correct.
That is
Sounds fairly similar to the rest of the distributed logic in NSX at that point.
It is actually very, very similar, the distributed nature of it, and which is amazing because you have a traditional underlay, which is just physical, configure one thing at a time, and you see what they introduce in the concepts of, we got to automate this, make it easy to do, concentrate the control plane, remove it from the individual components, and put it in a separate entity that is easier to manage. And that gives you the power to do so much more efficiently, and at a reduced cost.
Okay, so actually you mentioned provisioning and automation there. So would you care to elaborate on perhaps any additional functionality with NSX and or Brocade VCS with respect to provisioning?
Yeah, so another thing that you can do besides the one that we showed earlier, we showed this one, the auto provisioning for the layer 2 clause. You can do the same thing if you have a layer 3 clause and the steps are going to be exactly the same. Further, if you have an automation entity like a cloud management platform that can talk the BCS APIs, it can automatically send API calls to the cluster, to the fabric, to have it make configuration changes as you wish. So if you had, let's say, something like OpenStack, where there is a plugin from Brocade for it. You can have OpenStack and a set of commands to NSX and another set of API calls to the fabric, and the two can then harmoniously start communicating with each other.
So you are telling us that you can have a single console to manage both the physical and the virtual networks?
Single pane of glass.
Oh, that is amazing.
All right. So, are there any other specific pieces of special sauce that you would say perhaps exists within the VCS fabric as a differentiator?
So as I had mentioned earlier, the VCS fabric itself was built from ground up. We looked at traditional switches being given by different vendors. We looked at what the problems were with those things, and we set to build a fabric which is highly automated, right? So we talked about the automation features. I would also like to talk about multipathing features that are available in VCS. So we talk about multipathing in terms of layers. So we talk about multipathing being in layer 1. So if you have, for example, multiple links that are going between two switches in the VCS fabric, you would get frame-based load balancing between them. So typically the problem in a data center environment is that you might have certain flows which are much more thicker than other flows. So we call those flows elephant flows. So the bigger problem is that one link ends up being saturated and the other links are not being used so well. With frame-based load balancing, what you get is equal utilization between all the links that are connecting the switches. In addition to that, we do layer 2 based multipathing as well, which means that you can do, if you have a leaf spine architecture, for example, the leaves would be able to equally distribute the traffic between the multiple spines. And if you were to connect a layer 3 device to the fabric, like a router, then in those cases, you would do layer 3 ECMP, which is the traditional 5-tuple based ECMP. So we do multipathing at several layers so that you are realizing efficiency and resiliency at all the different layers.
Yeah, and I think the elephant flow determination has been something that's been relatively more recent, that it keeps getting used. But for a lot of the VMware purposes, you're typically going to see that during like a virtual machine live migration, something of that nature, where you have a long sustained part, and that really becomes a problem at layer 1.
Absolutely, and we understand that problem, and that's why we understood that frame-based load balancing is probably the best way to manage the situation, because even with different flows, you might have different packet sizes, which would lead to inefficient utilization of multiple links. With frame-based utilization, our statistics say that you would almost exactly have the same utilization across multiple links.
All right. You guys have anything else you want to share?
No, I just want to say that I think that Brocade and NSX, they're better together.
Absolutely.
All right.
All right, thank you, folks.